All right, everyone. Today, for our fifth grade Elevate groups, we are working on understanding equivalent fractions. Just like yesterday, we are anchoring ourselves first in fraction models before moving on to understanding equivalency of fractions in a more procedural way. So students are going to start out by looking at fraction strips to understand how maybe 1/4 is the same as 2/8, right? And then they go into the procedural way using multiplication. So, in order to first understand equivalency, we have to provide students with the definition, which is fractions that name the same value but have different numerators and denominators. So, 1/4 is the same as 3/12. I know some educators like to use the concept of pizza to explain equivalency. So educators will say, okay, well, I have this pizza pie right here. If it's just me, I get to eat this whole pie. However, if there are 4 of us who live in my household, I need to divide this pie into 4 pieces, right? Did the size of the entire pie change? No. The size of the pie was equivalent when I didn't have 3 other people to share it with. However, the sizes of the slices of the pie changed, right? Now, what if I needed to share this same pizza with 7 other people? So now I'm breaking it up, sorry about the noise, into 8 slices. Again, did the size of the entire pie change? No, it did not. What changed was the size of the slices. And so that might be an example that you want to roll out to students so they can conceptualize equivalency of fractions. And then another piece that you want to stamp for students before they jump into the conceptual piece of the lesson today is around this question. I would say launch students into a 2-minute turn and talk to see what they already know. But this is a nice discussion question. So Cole says the value of a half changes when you multiply the numerator and the denominator by 4, right? So I'll do this question right here. So Cole is saying that the value of half changes when you multiply the numerator and the denominator both by 4, right? So I know that 1 times 4 is 4. I know that 2 times 4 is 8. Yes, the part and the whole did change, but the value is still the same. How do I know that the value is the same? Well, because I am aware that 4/4 is 1 whole, right? So it's the same concept as saying, well, it's the same concept as saying, well, what's 2 times 1? 2 times 1 is 2. What's 6 times 1? 6 times 1 is 6, right? 4/4, the value of 4/4 is 1 whole. So this is saying the same as 1/2 times 1 whole is still 1/2. If I were to go ahead and simplify 4/8 by dividing it by 4 again, dividing it by 1, I would still get 1/2. So because I multiplied 1/2 by 1 whole, my value doesn't change, right? And so you want to stamp this idea for teachers that for students, that multiplying a factor by 1 results in a product equivalent to the factor. The value is going to change if students are multiplying that fraction by a numerator that is different from the denominator. If they want to find an equivalent fraction, they need to multiply by the same numerator and the same denominator, okay? So then you are going to jump into a model for students of equivalency, right? So we see here, one second, we see in question A that we have 2 models. They look about the same size, right? One model is 2/5, and then in the other model, it's showing 5/10. And really the question becomes, is it equivalent? Well, yes, because if I went to go ahead and divide that 2/5 by 2, I would end up with this same model right here. So it is the same. Then you're going to go ahead and also model for students the multiplication way. So it tells you that they want you to find an equivalent fraction for 3/4, but using a fraction that equals to 1, specifically 3/3, right? We talked about this. The numerator and the denominator have to be the same if you're going to create an equivalent fraction. So they want you to use 3/3. That's what we're going to use. And so when we multiply, we get 9/12. 9/12 is equivalent to 3/4. We know that it's equivalent because we multiplied by the same numerator and the same denominator. Now, you might want to go ahead and like have different tables multiply by a different fraction that's equivalent to 1, and then on the board you want to list out all those equivalent fractions to stamp for students. Even though we got a different answer, all of these fractions here are equivalent to 3/4. And then we're going to roll out into some practice time. Again, it's always up to you whether you want students to work on this independently or you want them to work on it in a group. However, as you can see, there's a mix of models, and then there's also a mix of the procedural way. For questions 5 and 6, students are going to have to gauge equivalency, right? So students are going to have to look through two fractions and see whether they are equivalent or not. In this question, for question number 5, we see that 5 times 3 does give us 15. We also see that 1 times 3 gives us 3. So it's perfect. Yes, it is equivalent because I multiplied by the same number and I got an equivalent fraction. However, for this question, I know that 3 times 1 gives me 3. Nice job. But I can't find anything to get me from 7 to 9. Or in other words, 7 times 1 does not give me 9. So this is not an equivalent fraction. So then here we have some fill in the blank questions where students are going to have to find the equivalent fraction. Students are going to have to find the equivalent fraction based on the information that they have been given, right? So for instance, in this question number 1, they are multiplying 2/3. They have to figure out what they need to multiply 2/3 by in order to get a fraction with the denominator of 6. Well, we know that 3 times 2 gives me 6. And again, whatever I multiply my denominator by is what I need to multiply my numerator by. So I would need to do 2 times 2 gives me 4. Then launch them into 5 minutes of their exit ticket. It's out of 4 points for today. And then release them to iReady when they're done.